Hello everybody, and this is the second part of the Adult UCI dataset, and we will jump on to data visualization and model building process. So, without wasting much time, I'll just give you a brief of this adult UCI that we have to predict that the adults making income. They have to predict the income is whether it is greater than 50,000 or not, and we have loaded the libraries. This is the data set which has like around 48,484, 42 rows and 15 columns. We have dealt with the columns. We have seen the value counts. We have replaced this question mark with mode, and we have seen how to do that. Then we've done some feature engineering. We have reduced few columns of education, marital status, and the income. And now we will move on to the data visualization. Actually, firstly, I have to show you something regarding correlation. Let's figure out what is the correlation. And this correlation is for the numeric data. These are the numeric integers which we are seeing. And we see that the figure that there's no as such high positive correlation. It's just normal to moderate correlation among variables and with income and age, and as you can see, this is negatively correlated, negative sign. So we don't have to bother much about this because this is not so much of a concern. And if you want to plot this, we will use heat map for this. So we will use this heat map, and in this I will write df.corr, and in that I would take a note as true because a note will give me the values inside. So I will use this, and let's see this. Okay, so you can see this, the correlation, all the values have been written inside, and how each feature is linked with the another. Income and age has 0.25 correlation. So this is figuring somewhere here, which is weak. That means it's like if you've got greater age, your income might possibly be into the bracket of 50,000 and above. But we have to figure it out. It is not that evident from this. So this is just give you an overview about the correlation, that there's not so much strong correlation with variables, but yes, there is certain like weakly correlated correlation that we can see here. Now I come to another part of it, and that is we will find the shape of the data, and that is through histogram. We will find this. So for this, I have to plot the histogram for the entire this numeric data. Histogram is being plotted, and then I will go for fixed size. Fixed size equals to 12,12, and here you've got layout as 3,3. I'll show you how this layout works. First, let us just see what is in store for us in this. And how does this comes out, this histogram. So you can see the histogram now. You see that we've got around 7 variables which have been plotted. Age, and you can see the distribution of age here. This age is spread from like around age from 17, because we know that from description it is 17 to 90 years, and the most of the age group lies in the bracket of 20 to around 50, right? Similarly, you can find it for capital gain. It is from 0 to somewhere around 1,000, 10,000 or so, 1,500. Capital loss, and these the values you see here, which are really small, these are also outliers, and we will see these outliers separately with box plot. And similarly, you can see this hours per week. So maximum people working in this bracket, in this range, like around 25 to 40 hours per week, and few are really going extra miles, like around 99, 80 hours per week. So they are really very hard workers. Okay, and there are very few who do not even work 1 hour per week. Okay, luxury. Okay, so this income, as you can see here, we've got this people who have got like less than or greater than less than equal to 50,000. It's greater than 35,000, and the people who have income which is greater than 50,000 lies somewhere around 11,000 or so. So this is how you can infer from the histograms the count and the frequency of its occurrence. Another thing, the layout thing, if you want to observe, now remember this thing, 3 into 3 is 9, okay? And the layout is like 3 into 3, 3 rows and 3 columns. What if I change this to 3, 2? it will give me an error because it must be larger than the required size 7. We have got 7 features to be plotted, but I am giving it a feature of 6. So I need to increase this. Either I increase this to 4, so that means there would be 4 rows. Okay, so there will be 4 columns and 2 rows. This is how it has arranged itself. Now what if I just reduce this to 3? So this will give me 3 columns, and here I will increase the rows. So rows have to be increased in such a way so that it is greater than 7. 4 3s are 12. If I use 3 3, that makes sense. If I use here 2, that means 2 rows, and I increase the columns to suppose 4 or say 5, then it will be congested, it will just accumulate here. Let's see what happens here. And the figure size is 12, 12. It becomes a little congested. It doesn't look nice. So I will just reduce it, and I just restore the previous layout of 3:3, 3:3, and this looks more nicer. Okay. Now for the box plot, we just keep experimenting with things. Things would be clear. So then box plot, what I do is I would use this df dot plot, and in this I will use the kind equals box, and the fixed size is, again, I can give 12, 12, 15, 15 as per my wish, as per the features it is plotting, number of features. And this layout is again 3, 3 because there are 7 this thing, and it is plotted for numeric data, and share x is false. I'm not sharing the x-axis, and I will write here subplots equals true, and you have to mention this thing. And I just hit shift enter, run this code, and now I get the outliers. These are the extreme values in my data set. So I have it in almost all numeric data. Like age, I have this extreme values, which is like around the most of the age is lying in the age group of, like, as we've discussed in histogram also, from 20 to around 50. But you have people who are in the working age group who are above 50 to exceeding to 90 or so, and very few people here like in the 80 to 90 age group. Similarly, you can find here with the educational number and hours per week. So most of the people are working around like 40 hours per week or so, and these are the outliers who are really not working at all and who are putting extra efforts. So we can see it here with the box plot, the outliers. Outliers affect our data set because it kind of make bias predictions, give more weightage. Now we come to Plotly, and we shall see how to plot with Plotly, and we'll be going with the pie chart. Okay, so I will use pie to show you the distribution of the data, and we will use values as educational number because it has to be numeric, the values which is being plotted, and in the names I will use education because I want to show you the percentage of education, and I can use the title if I want, and I can just write here percentage of education. Just to make it short, I will write here percentage of education, and I can use the color discrete sequence, so I just use this. I had pressed shift plus tab to show you what is there. So I just copy this color discrete sequence or control, and I will paste this here. So this is color discrete sequence, and this color discrete sequence comes out to be, I can use the syntax as px dot colors dot, I'm using qualitative dot, I'm using t10 here. Let's see what comes out. Okay, what is it? Values. Value of values is not name in column of data frame expected. Okay, I have written the wrong spelling. That means educational number. Okay, this is not underscore, guys. This is this. Okay, yeah. Done. So now it should plot it, and when it will plot, I will quickly take you to another plot show you how it plots. Plotting will take a little time because it is plotting the education number and everything. So here we are with this. Okay, we have reduced a few dimensions, a few features in this education column, and so we've got just reduced it to like higher school, undergraduation and all. So you can see that the higher education has the highest share, that is 33.1%, and followed by this high school, then undergraduate, graduate, school, and the doctorate. So it's the lowest, like 1.93% of doctorates, right? Okay. So this is what your percentage of education is showing in this plotly chart. Now I will show you something with SNS. Now let's come to SNS count plot. Since we have got various categorical features, I can use count plot here, and I will find here race because I want to see how this race is interacting with different things. I will see here hue equals to income, and I want to see the income of this. Go to the data is df, and I'll use the palette, and the palette could be like, give it magma. Let's see. Okay, now why I use this semicolon, can you see this matplotlib access subplot? If you don't want this, just use semicolon and this would be gone. Okay, you will just have the plot. So you can see here this race being plotted on x-axis, and the count you can see here in y-axis. Actually, this count plot is a kind of a histogram for the categorical variable because I want to see the count, and I see that the white have got the highest income, and they are highest in the number in this data set. So we can find that their income is high in both the cases. Then black is in the population, and then we've got Asian, Pacific Islander race, other American, Indian, Eskimos is the lowest. Okay. Okay, so this is the data which we can see here. Now you can experiment with this, like you can have your occupation and let it be income, and you can see, okay, this is a little haphazard, so I can write here, let's take here education. Okay, so you can see in education you've got hue income. Now if you don't want this, you can just play around with this. You can take here gender, you can play around with the palette and just take here like I think I can take seismic. Seismic. Okay, right. So you can see that male and gender and their count in each of the education category, and you can see that females are much lower as compared to males, and you can see in high school you've got the highest number of males, and then followed by this in higher education. Okay, so you can just experiment with different and various features here. I can use race, education, gender. I can change hue and see the variations with that. Now without wasting much time on data visualization, I would come on to something. Now if you want to explore more, please visit this website. I have done it in more depth and description. You can just see here what all things need to be seen here with data visualization, and it's I would say, okay, so you can just see these visualizations here and the key findings and observations which are also being written. Okay, so now we come to the model building process, and for model building we have to just first of all, I'll give you go by step to step, and I'll explain you how do you really do this. And what I do it, I create an object called x, and in this I will store df dot drop, because in my x I have got the entire data. I have also got the output here, that is the income, and I don't want income to come because I will store it in y, and I just have to train this x to map it with the output. This is what we do in machine learning. So I have to first separate it, and access is equals to 1, and in y object I will create this df. I will put this into this object, right? This is the dependent variable and x is the independent variables. So you just press shift enter. Now what you do is you come to some feature scaling. You have to scale the data because you have to make sure that each and every um, values are of the same magnitude and none of the features are given more importance. So what I do is I will import a package from sklearn preprocessing. What you do is import standard scalar. I'm using standard scalar, and also you import label encoder here, right? Label encoder. So when you're done with this, what you do is you can make a copy of df.copy and copy one, store it. It's a good practice if you do it because your df will not be disturbed for this. And then you've got df1 equals df1 dot apply. What will I apply in this? I will apply label encoder here because this label encoder will bring all the categorical values into either 0 or 1, or change it into numeric format, if I can say. This will also help this code make it more machine readable. Label encoder does that, right? So okay, I'm halfway this transform, and then I will see df1 dot head, and this is something like that. So you can see here that the education has been converted into like 1 2 3 4 and so on. The work class was categorical, it has been converted. The occupation had also been converted into numbers. It has assigned numbers to each categorical variable. You can see marital status 0 1 2. This is how it works. So label encoder just fits your data into machine readable format. Okay, the native country, can you see that it has assigned values for each of this? Okay, now we come to something called SS. I create an object wherein this is the standard scalar. This is standard scalar, and this will be dot fit. And what will I fit here? I will fit my df1, and in this what will I do? I will drop. Okay, I've already dropped this, but again it's like df dot drop income, because I dropped it in for x1, that is df, and now I'm dropping it for x is equals to 1 df1. Okay, not finding axis. Okay, this has already been dropped, right? So it has not found, that's why it's not finding any axis. So now what I do is I will write here x is equals to ss dot transform. I will transform this df1 dot copy, df1 dot, okay, transform this drop. Let's see how it works out. Income x is equals to 1, and here y equals to df. Here I will write income. Let's see. Okay, standard scalar, I have defined standard scalar. I haven't defined standard scalar yet. Okay, I will define the standard scalar and I make an object called ss is equals to standard scalar, right? Yeah, so I create this standard scalar, transform. Okay, I usually do this spelling mistakes. Standard scalar dot fit. There are some glitches here which I just need to fix it. Just bear with me. I think this is df1 dot drop, and I have to drop this, and it is dropped, and this is income, and I will take on to x's where it will locate it as 1. Okay, Finally, this has been done, guys. So what was the problem? That was I created an object standard scalar, but it was asking for fitting it. I have simply transformed that. So I had to first fit this and then you perform transform. So this is a thing that first you fit the data set, and I have fitted this data of df1, and I have sorry, this is again like df.drop. Okay. Then I have fitted this data in df1 and df1.drop. Okay, and after fit we perform transform. So this has been fitted. I have dropped the income column here. So now and I have told it to transform this data, drop this income, and in y you store this income. Since I have created df1, I had to do it again. I did it previously for just df, but now I have to do it for df1 because I created one df copy just to be on a safer side. So now it has been done transformed, and now we will perform some train test splits. So from sklearn.model selection, what I'll do is I will import train test split, and here I will write here xtrain. This is the syntax: xtrain, then you write xtest, then you write here ytrain and ytest. Ytrain, ytest, and give the train test split size. So then you've got train test split, and here you've got split x, y, and what is the test size for that? I will take its standard size, which is a practice like 0.3, 70% of the training and 30% on the testing data. And I will also take some random state, and that could be like 40 or 30. It is your wish. You can take 0 also. And you run this. Then what you do is, now I will be using logistic regression in this, and I will explain you two models here, two classifiers, that is logistic regression and random forest. So we'll go with logistic regression first. It is used for binary classification. Don't get confused with regression here. So I will just import this first of all. So from sklearn, I've not done it in the starting because I wanted to show you from where you want to really import it. So from sklearn.linear model, you find this logistic regression. What I do is I will import logistic. Be watchful with the spelling. Okay, logistic regression, and then you can go ahead again with from sklearn.metrize. I will also measure the performance of my classifier, that is logistic regression, with matrices. So I will use here matrices, and I will import. I will see the accuracy of it. So I will go for accuracy score, and I will create an object called LR. In this I will store the logistic regression classifier. So I will write here logistic, and this will be regression, logistic regression. You store in this, and then what you do is I will write here in an object I'll create model, and this could be LR dot. Again I have to fit this model, so I will fit here. What will I fit? I will fit X train, my X train, and Y train, because I want to train the model on this. So I'll fit X train and Y train, and then I will make predictions. So I will make prediction, and this prediction would be model. On this model dot predict what? Predict what? X test. This is my X test prediction. I also want to show you something like model dot predict. You can add one more thing if you want to test this. What I'll write here is I will write here print accuracy. I'm just like using the short format accuracy of or accuracy on the training data set. So I'll write here accuracy on training data, and this will be somewhere around. I want a format for this, and I'm giving it a format. I want till 3 decimal places, and floating point variable, and then I want the format. So I will write here more dot format and the object lr dot score, and this in score I will write here. Let's take x. Okay, here x train and y train. Right. So what I'm doing is I want to print the accuracy of everything. So that's why I'm using this, and again I will copy and paste this, and here I will change here from training to test data, and the format will be the same, and here dot format lr score here will be x test and y test. Okay, so I'm making predictions on x test and y test, and let's just run this. So this you can say that on training data set it is performing something around 83.8, and on test data it is like 83. This is my logistic regression. And the next thing I want to show you is about random forest. So just let's just do for random forest and check whether is there any improvement. So random forest classifier, again we shall just call it and see from the module from sklearn, again dot ensemble, they are under ensemble, and I will import random forest classifier, right? And then I'll create a model for that. I'll create an object for that, RFC. In that I will store this random forest classifier, and I will call it as and when I need it. So I'll just store it, create an object, and then I will create model 1, and in this I will use this RFC, this random forest classifier, and I will fit it. What will I fit? I will fit X train, and I will fit Y train. Okay, and then I will make prediction, and prediction 1, say, because this was prediction 1, so prediction, so this is prediction 1, and here I can write model 1 dot predict. It will give me the same thing, I can just write here X test and you can just run this. But I also want to show you that I have to print this entire thing. I will print it here, Control V, and here instead of LR I can write here RFC, that is random forest classifier, and here could be RFC, and then you can just go ahead and see what accuracy is this giving me on training and test data set. And till the time it is running I can simply just from sklearn dot matrices I have to import confusion matrix, because I want to explain you about confusion matrix, and this is the right time to delve into confusion matrix. It is not confusing, but this requires a little practice to understand confusion matrix. Okay, I will import the classification report also. Classification report. And accuracy, since we have already done, so I will not use that. Okay. So now you just again spelling MET. Okay. Pardon me for this. Classification. Okay. It's not having some self-correction properties. Something has to be done for this. Okay, so you can see here that on training data set I have achieved 100% accuracy with the random forest classifier, and in the test data it is 85% accuracy, which is greater than this logistic regression, that is 83%. You can try with different classifiers, like you can use decision tree classifier, you can use KNN, SVN, SVM, and so on. But I have right now, we just stick to this thing. And now let's begin to print our, I'm doing it for this only, so I'll print the confusion matrix. Confusion, what is it? This is confusion matrix I will print, and I will print it on what? Y-test and predictions. Actually prediction 1. I can do it for the upper prediction also, but I will take this prediction because this is giving me a good accuracy. So I will use this prediction, and I will print the confusion matrix and also explain you what does this mean. So you can see here that I am getting 10332, 806, 1286 and 2229. Let me just print the classification again, spelling, classification report. And in this classification report I would just use what? Y-test again, and Y-test and predictions, making it on predictions, prediction 1. Let's see. So can you see this classification report? Now I will use classification report and confusion matrix to understand, to make you understand what is this confusion matrix all about. You understand this precision and the recall. So precision, how is precision calculated? Precision is actually true false, true positive upon true positive. I'll write it down for you. So this is actually true positive divided by, I can write here, true positive plus false positive. Now identify here what is true positive and false positive. Now since I have not assigned it, now you have to figure it out what is what. So I will just show you with the calculation. I will write here so that you understand and follow with me. Precision. Now we are finding the precision, and let's just, this is interesting. How do we do this? True positive for the first class I'm finding. Okay, this is actual and predicted. I'll be coming up with this confusion matrix theory video to understand, to make you understand how this really works out, but the practical session, understand this thing first. This is true positive. I will use here 10,332, and you divide this by, again, true positive, so we don't have any problem because we know what is true positive. And then you come to false positive. What is the false positive rate? So this precision tells me the correctly identified cases or instances that my algorithm has, or my classifier has rightly predicted, only the positive instances. So false positive, what is false positive here? False positive is 1286 here. Okay, so you write here 1286. This is your false positive. So you go for precision like this: true positive plus false positive. So when you print this, you will get here 88.9. So that is right, round approx 89% precision. That is what we are getting for the first class, and this first class is less than equal to 50,000, and I'm getting a precision of 89%, that my classifier is able to predict correct instances, which is 89% precision. Now I call about recall. Recall means the negative or the missed out positive classes which my algorithm has really missed. So if I just tell you about the formula of recall, this is true positive rate, and this is important to identify because here you find out the missed instances of your classes. So this is about true positive divided by, I will use here true positive plus false negative. The negative, that means the missed instances of my class. And now here, how would you identify this thing for the first classes? I will print here recall, and I'll go with this thing. I'll go with true positive. Again, I know true positive, I have no problem. I can just simply write here 382, and I divide this by the entire thing. Now true positive plus false negative. What is true positive here? Again the same thing, and this is 10332 plus false negative. Now come to false negative. What is false negative here? This is false negative 806. Okay, and you print this. So this is 92%, 92.7, round about 93%. Now this one, remember, this one is for the first class. What about the second class? The first, this is the negative class. Now for this again, we have a different formula. We have the same formula, but we will just interchange the values. Okay, so we just interchange the values. I just want to see this confusion matrix. See, these are closely linked. The classification report will give you the precision and recall. But if you have got confusion matrix, you can find out precision and recall. And this is how I am telling you how do you really find this. True positive, you locate true positive, you locate true positive, false negative. So what remains here? This is false, this is true negative. Okay. So I just mention it here that this is what? This is true positive, this is false. So you can just see this and correlate this with the numbers. Now I come to for the class, for other class, and that is 1, and this means that this I'm predicting about greater than or equal to 50,000. Now again, now I have to print what I want, precision. So I'm just calculating the precision here, and this precision would be what? Again, true positive upon true positive plus true false uh, positive. So here I know the true positive. What is true positive here? This one for this class. Okay. So I'll use this here. That is, so you have to identify it, and you will understand it when you will do the practice. When you will do it yourself, you will start understanding all these things. How does it really work? So I'll use this here. Don't just tighten up. It is easy once you start interpreting this thing. It will be easy. You have to write it down and see how it works for you. So plus 806. Okay. And I will just print this precision, and this is 96%, as you can see here. Where's my classification report here? Okay, no, this is not 96%, this is 73. So I'm getting something wrong here. I'm fitting something wrong, some wrong value here. Okay, yes, here 22291. No, still it is wrong. It is not 96. It has to come 73. So there is something wrong. 222806, and this has to be for the other class precision 2241, 224, 222229. Have I mentioned 2229? Why is it 1229? Okay, yeah, fine. 73. I added extra one here, which was not to be added. So now you get to recall. Okay, and in this recall, I will add what? True positive. Again, 2229. I'll be cautious this time. And I will add what? Same 2229, and now I want the false another number, and that is here 1286. 1286. Okay, so I'm getting recall of 0.63 for the another class, and this is what my classification report also says. So the correctly predicted instances for the second class by my algorithm or classifier is 0.973, and it is giving me a recall of 0.63, which is not that bad, but it is not that good also. That means I'm likely to miss a few instances. Okay, I'm likely to miss instances in this class, and you can see these missed out cases here, 806 and 1286 wrongly identified cases by my algorithm. And this F1 score is nothing but a harmonic mean between precision and recall, so need not worry about that. So this was about the accuracy, or you can say the confusion matrix, which has been explained in detail here with formula, and this has to be taken in unison. What is confusion matrix and classification report? One can derive confusion classification report from this confusion matrix itself. Okay. Support penalizes the wrong instances. If you are making wrong instances, you are being penalized for that. You are punished for that. So this is about this thing, the accuracy. So random forest classifier is giving you good accuracy on test data, 85%. This can further be boosted with gradient boosting. You can use add optimizer and other different ensemble techniques to boost or to improve this accuracy. Also, you can use hyperparameter tuning. So there remains a lot of scope to improve the performance of this basic model. This was just a basic model. You can improve upon it if you are really interested in it. So this was about the model building. We've dealt only with two. If you want more, you can just visit the website and explore different regression techniques here. Okay. So that's it for this video, and thanks for watching, guys.